All right, so here's our first slide with our learning targets. So hopefully you're starting with your study guide open so you can fill that information in. You're like, where's the study guide? You probably didn't watch that instructional video. Probably want to open that up. So you're filling in your study guide as we go through this. So the first lesson is just a short couple of slides. So our first learning target is I can explain how atoms form covalent bonds to share electrons and form molecules. And then the second learning target is I can explain hybrid orbitals and how they determine the shape of molecules. All right, so this first learning target, it's really just review, right? We understand covalent bonds are formed between nonmetals and that they share electrons. This hybrid orbitals is a new concept that we're going to be doing. So remember, we have three types of bonds that we've talked about this over the course of the semester. The first was metallic bonds and ionic bonds. Those are the first two. And then we're talking right now more detail about the covalent bonds. So remember, ionic bonds, what are they for? What are they between? They're between the metals and nonmetals. So here, sorry, all the background noise. Full house up in here. All right. So everything going in this direction, right? We consider those to be our metals, and everything going in this direction is our nonmetals, right? So nonmetals over here, metals over here. And our ionic bond is going to be between metals and nonmetals. An example would be sodium and chlorine, salt, right? The sodium has a valence electron that it transfers to chlorine. So remember, we find our valence electrons, those are our outermost electrons. You can just look at this group number. That tells us how many valence electrons we have. 1, 2, right? Skip those guys for now. Over here, 3, 4, 5, 6, 7, 8. So that should all be review for you guys. And then our metallic bonds, two metals. So we did that lab with zinc and copper, right? With the penny, made it all shiny. So those are two metals. And so they're very similar, right? They share electrons. Electrons are moving freely, right? And then our nonmetals are going to be our covalent bonds. All right. And we talked a lot about this. They share electrons. And they share electrons to do the same conceptual idea as the ionic bonds. Ionic bonds want to be stable, right? These guys want to give up electrons. And these guys want to gain electrons. With nonmetals, they share electrons. So we did a lot of examples. Fluorine was a good example, right? Fluorine is in this column, so that's 7 valence electrons. So it wants one more. So here's another fluorine atom comes along. It also has some electrons. And then it's going to share these two electrons, and that's the covalent bond. Okay, so we're going to look at this in more detail on the next slide, and we're going to start adding some ideas and concepts. So for now, you guys should be able to fill in on your study guide the definition for the covalent bond. You should already understand the definition of a molecule, and you should already understand the orbital, but we'll talk more about orbitals in the next slide. So remember that molecules, right? That's when atoms are held together by one or more covalent bonds, okay? So that's what you be including down there for your molecule. And you should also be able to start to fill in some of those statements in the study guide as well. Okay, so now we should be able to get into orbitals, all right? And so remember, periodic table is our roadmap. So if I go up here, I draw a little S, right? So hopefully this is all coming back to you guys. So the valence electrons for different sublevels, the sublevels are made up of orbitals. So the s sublevel has one orbital that can hold two electrons. So S, so these guys have one valence electron in this column, so they're going to be S1. And then these guys have two, S2. Remember, group number right here tells us that. So now when we get over here, we have 3, 4, 5, 6, 7, and then 8. So how do we get to 3, right? Because with our S, we have 2. So then we have the P sublevel over here. And then P can hold up to 6. We put 1. That gives us 3. And then we do the same thing over here with carbon. S2, P2, that gives us 4, right? And so on. And then here, we get totally full. We've got the 6 valence electrons in the P and the 2 in the S. Remember, this is review. So if this is confusing, you definitely want to go down to the Google Classroom, take a look at Q3 materials and review this stuff. Because if this is new, you're going to struggle to keep up. But if this is good, then you should be all right. So remember, S, that represents the sublevel, and it has an orbital that can hold 2 electrons. Each orbital holds 2 electrons, okay? So P has 3 orbitals that can hold up to 6 electrons. All right, so you should understand the orbital piece now. All right, so remember, group number tells you how many valence electrons, and from there you should be able to extrapolate. Extrapolate means figure out how many electrons are in each of these orbitals, right? So we fill S, it's either going to, so we get over to our nonmetals, S is filled, it's got 2, and then a P is going to be 1 through 6, right? Because we're just looking at nonmetals. Covalent bonds are only formed by nonmetals. So this is what you need to remember for this stuff, right? S is filled over here, right? And then we add from 1 to 6. All right, this is the last piece of this first lesson. We are going to look at how we're finally going to get into some molecules. It's very exciting for me, actually. So remember, chemistry is the study of matter, but it's also the study of change. All right. So now we're going to get some atoms together and things are going to start to change. So here we have a representation of different orbitals and what happens to them when they form these covalent bonds. So here's an example of the 2s. All right, so we think of this as a sphere that can hold 2 electrons. All s orbitals hold 2. So here's the p. Remember that we did this briefly, right? We had the p, it's in 3 dimensions, right? So it has 3 orbitals that can hold 2 electrons. So in each of these there's an electron, right? Or there could be, right? So this gives us the p, and this is in 3 dimensions, right? So what happens? So if this is carbon, carbon has 4 valence electrons. I know that because of the column it's in, and it's going to have 2 electrons in the S and then 2 in the P, right? So if this is carbon, right, it's got a total of 4 valence electrons, and it's got 2 in this S. Just draw 2 right here, and then it's got in the P. Remember, we fill the orbitals. We spread them out to make them happy. So that's where we get these. So now what happens when this guy forms a molecule? These orbitals are going to form hybrids. So the way that these orbitals come together and form hybrids, can understand it in terms of electron configuration, right? So here's my S, increasing energy. and here's my P. Right? Each of these lines represents one of these orbitals. So each one of these lines is like this, or in the S, let's case this. So remember, we had 4 valence electrons. So we've got 2. And we spread our electrons out. So we're going to make a molecule of methane, which is carbon and hydrogen. Okay. So what happens is when these guys get close together, they form hybrid. So the hybrid is lower in energy. It's between the S and the P. So how many orbitals do I have total? I have 4. I get 1 from the S, and I get 3 from the P. Right? So these guys come together. Right? Got 2 in the S. But we want to spread them out, right? Now we've got these hybrid orbitals. So this is going to be more stable. So there's my 4 valence electrons, right? They formed the sp3 orbital, right? So now it wants 4 electrons. So get my eraser, so it's a little easier. Let's get rid of this guy. Oops, that's not my eraser. There we go. Let's get rid of this guy. Get my pen. So now what happens, and this kind of shows it up here, this is my carbon atom, right? So each of these hydrogens have come in and they've each got an electron, right? These each have an electron, right? So they come together. So this is the 1s from hydrogen. And then the sp3, there's 4 of them, right? S and P. So they share electrons. 1 electron here, 1 electron here, 1 electron here, 1 electron here. 1 electron here, 1 electron here. Electron here, 1 electron here, right? It's more stable, right? Oops. That's energy, right? So it's more stable to form this hybrid. And it also gives us this shape, right? Call it a tetrahedral. It's just a fancy term, right? Forming these hybrids gives it this kind of shape. So that's the hybridization piece, all right? So hopefully all this makes sense. That's our new piece, all right? So we have the hybrid orbitals. They determine the shape. And take a look, if we count all these up, how many electrons do we have? 8. 1 from each of the 4 hydrogens, and then 4 from the carbon, right? Look at our noble gases. 8. Stable. So similar to ionic bonds where they're transferring electrons to get the configuration they want, they're sharing electrons to get to the configuration they want. All right. All right, so go ahead and complete your study guide for lesson 1. You should be able to fill in those statements. Start thinking a little bit about the soap, okay? This is a soap molecule. Remember back, we did our video with the initial ideas. So these are all carbons, they just don't fill them in. This is like a nomenclature thing, right? These are all carbon. And off of these here are hydrogens. Okay, they just don't fill them in. It's an organic chemistry thing, right? It's just simpler that way. It's sort of like when you have an ion and you don't write the number and you just write the symbol, so you assume if it's a plus or if there's no number there, right? Same idea.